Alright, in chapter 10, section 2, we're looking at hypothesis testing with proportions. So, there's a couple requirements that you have to make sure are satisfied before you can use this test. So the first one is n times p times 1 minus p has to be greater than or equal to 10. So we could verify that pretty quick. And do our sample size is 125 times 0.2 times 1 minus 0.2 is the 0.8, and so it's greater than 10, so that we can check off. And so now we need to find the p-value. So we're just going to use technology to find the p-value. There's a couple different approaches. One of them is looking at critical values and seeing if the test statistic is within the critical value. The other one is the p-value approach, and that's the one that I honestly prefer. So we're going to go to proportion stats because we're dealing with proportions. We have one sample and we have a summary of the data. So looking back at the question, we know the sample size is 125 and we had 30 successes. So 30 successes, sample size is 125, and we're doing a hypothesis test. So the null hypothesis was that it's 0.2, and we're seeing if it's greater than 0.2. So all this information is given to us. Later on we'll have to figure out if it's greater than or less than, but right now we just type this in and it'll give us a p-value. So this p-value is 0.1318, which means about 13% of the time we'll have something similar to this. Now, what we compare this to is our alpha. If our p-value is lower than our alpha, that's when we will reject the null hypothesis. 3 decimal places will be a 0.132. So, if the p is lower than our alpha, we will reject the null hypothesis. Fun little saying, if the p is low, the hoe gotta go. So if the p is lower than our alpha, we would reject the HO, reject the null hypothesis. So p is low, hoe gotta go. So since our p-value is higher than alpha, we would not reject, we would fail to reject, because the p-value is greater than our alpha. So that's how these type problems work. Another one to look at is number 8. So this one we're building it, we're making the hypothesis statement. Already know before even reading it that this is equal. Our null hypothesis, we're always going to have an equal. So in February 2008, an organization surveyed that many adults and found that 534 believed they would not have enough money to live comfortably in retirement. So this was done in 2008. Does the sample evidence suggest that a majority of adults in certain country believe that they will not have enough money in retirement? Well, what does majority mean? So they've given us their sample, right? And that somehow is going to what we're going to use to test our hypothesis. But a majority means we think it's about 50%. Our alternative is like we think it's a majority that would conclude they have enough money for retirement. So majority is greater than 50%. So again, from this, we had to interpret what our null and alternative hypothesis would be. So we got that right, good. And now it's finding the p-value. So we will go back into StatCrunch. We had 1034 and 534 believe they would not have enough. Oh, this is would not have enough. So again, greater than 0.5 is still a majority. So 534 and 1034. Let's look at that. And again, since we're dealing with proportions, we go to proportion stats, one sample, and with summary. 534 said that they would not have enough out of the 1034. 0.5, that's what we're looking at. And again, if we want to see if it's majorities, that means more than 0.5. So a greater than. It makes it a one tail. And we find our p-value. 0.145. And then lastly, what are we going to do? Are we going to reject or fail to reject? Now this one, we're comparing it to alpha, which is 0.1 or 0.10. Since our p-value is greater than our alpha, we do not reject the null hypothesis. So if the p is less than, we would reject, but the p is greater than, so we do not reject the null hypothesis. So that would be this one here.